Welcome, I'm Bill Wake. This is my weekly summary of the work we've been doing on Twitch. Lately, we've been working on a compiler and interpreter for a language I'm calling 10th that's an imitator of 4th. And I thought we'd mostly be doing 10th work this week, but it was about 50-50 with primaries, keywords, and implementation in 10th. So we touched quite a few things. We implemented head dollar as a function to split strings so we can loop around them. We added end of line comments with the # character. We implemented in 10th our basically our X unit package, assert equals dollar, which is string equals, and assert equals strings. We defined a call method that calls routines named by a string. So this gives us a mechanism we can substitute routines. We didn't have anything, there's nothing like inheritance or anything in this language. All right, and so once we have those things, we can work on drawing the game title and the scaffold in 10th. And we added a test for our draw routine. Once we had the call, we did this with a spy to capture when IO was going to occur. And we started it on game over and initialized 2 parts of the hangman game. Okay, so head dollar is basically to split the first character off a string. So if you have the string BAR in the picture there, and who cares what's on the rest of the stack, it's going to turn into 98, which is the code for lowercase b as a number, and then the rest of the string AR. Okay, so it's taken off the first character. Now, if you had an empty string, we take the first character is a 0, the null byte, but we keep the empty string on the stack too. Okay, and so we'll see that in the code. The code, we come in with a string on the stack, so we pop it into X0. That gives us a pointer to the string. In 43, we load that first byte into W1, which is sort of the word version of X1. We compare that byte to 0. Oh, sorry, in 43, we also move the character pointer forward. So the X0 pointer is now pointing to the rest of the string. All right, so we compare the byte to 0, and if it's not 0, we go down to 49. If it is 0, we're going to back up the pointer 1 because we at the empty string, we want to leave it returning the empty string, so we don't want to move forward in that case. So here we're kind of retroactively back patching it with one lower pointer. And then either way, we go through the head string, and it's going to push the string address first, the X0, and then it's going to push the character second, X1. And this will give us a way to write our loops. All right, then we added this # for comments. I'm not going to show the actual implementation code. I'm going to show how you use it. And basically, because this language is so stack oriented, lots of times these comments are what's the order of things on the stack with the top at the left. So the head2 function is going to try and take 2 strings and put their characters, head puts the first character, of the string on top of the stack and changes the string pointer. We want to do that with 2 strings in parallel. So we can do basically, this is to help us implement equal string. All right, so we need to compare the 2 current characters of each string and decide what to do. So S2 and S1 come in, we call head dollar, and that splits off the first character of the second string. We do a cab, which is a rotate, so the S1 ends up at the front, S1, C2, S2. And then we do another head, so we have C1, S1 prime, C2, S2 prime. And then finally we do one more cab, so we swap C2 and get it into the front character. So now the front 2 characters of each string are on front, followed by the rest of the strings. And notice if you consume those front 2 characters and came back into head 2, you'd be able to move forward with the next 2 strings again. So this thing of keeping track of the stack, very, very common. The other big usage is, headers for the routines to tell what's the input and output effect. Okay, and then we use that, head 2 got used to implement equal string. I'm not going to show that one, but I will show assert equal and assert equal string. And you can see they're very similar. The only difference is a couple of critical places where it calls the string version on the right. So line 56 on the left versus 71 on the right. 56 is working with 2 integers. The one on the right is working with 2 strings. Okay, and it leaves a 1 or 0 on the stack, and we use that to decide if the string's matched or not. Since our first thing was to do a dupe2, which duplicates the 2 strings, okay, so, or 2 numbers or 2 strings, if it matched, we're fine. We'll throw those extra 2 numbers away. Notice 2 were consumed by the equals. So we'll pop them if they match because we don't want to do anything. We just want to get out. But if they don't match, then there's an error message. And we want to print error values differ. And then A, which is the top of the stack, and B, which is the second one down. And notice 62 is dot, pop, and L. So we're popping that duplicated value or the underlying value and after we print it. So we really did the dupe2 so we'd have something to print. Okay, and again, the string version's the same except line 77 $$ prints. So that's a string print function. Kind of a little bit cryptic for functions, but kind of borrowed from Forth. All right, well, once we have those, we can start doing unit tests. So that makes us happy. But before we can do unit tests, there's a problem. So we have a routine to draw the scaffold, and it's a lot of code, but there's only like 2 lines that actually do the drawing, and they're doing I/O. One moves the current point of the screen, and the other prints the string there. So it's not easy to test those, and it's very tempting, especially this, to just say, well, it's I/O, we won't test it. But then the routine that decides where it goes and make sure each line gets there, that really, the bulk of it has nothing to do with that I/O. And we would love to put something in there instead of the I/O, put in a spy like you would in Swift or Java or any other language doing a test double kind of thing. But we don't have a mechanism to do that. There's no inheritance, there's no generics, there's no other mechanism that would make it happen. So we're going to implement call, and call says, give me the address of a string, and I'll look it up and then call the procedure associated with it. And so we can choose how to get the string on there and then do the substitution. So this is kind of back a step from that, but here we go. So 82 x28 is being used as sort of a spare copy. X28, as registers go, routines that you call aren't allowed to trash it, but they are allowed to trash X0. So 84 will fetch the string into X0, pop it off. We'll make a copy of the string pointer to X28, and then we'll call dictionary search. Well, dictionary search destroys X0. It takes the string, looks it up, and then in X0, it does its return value. So it either returns 0 if it can't find it, or it returns the address of the routine you're going to call if you can, or the address of the address, I guess. So we compare, is it 0 in 88? If it is, we're going to call word not found. If it's not, we're going to do the actual indirect call. So we load the pointer to the code that we got back from the dictionary search, and we do a BLR, which is a branch through a register, so the register contains the place to call now. And once we've finished and returned from that call, we're going to jump down to call exiting and basically just restore X28. Okay, so the only other piece is 96 there. If the word wasn't found, we call word not found and we'll pass X28. Well, X28 was the pointer to the word that we saved up in 85, so it can print a message like, can't find word foo, and that macro called in 97 will do that. Okay, so this is the mechanism that's going to let us do some testing. All right, so we'll look at draw first, and then we'll look at the test. Okay, so we're actually going to start on the right side of the page in line 261 inside that box. It calls scaffold 635 draw at draw. So the way this language works is it pushes stuff on the stack. So first thing it's pushing is the array, the pointer to the array scaffold, then the row, then the column, and then the routine that you should use to draw things. Okay, so a draw at, in production, it's draw at. And then finally, we call draw, which takes those four things on the stack. So draw, basically the first thing it does is it's got the procedure draw at or whatever. It basically stores that into a variable called draw routine, so it can call it later. We initialize an index to 0, and then we save the column in a draw column and the row in draw row. Okay, and so drawing the column, it's always the same. We're just going to go down the same position. Drawing the row, we need to use that index, and so it's the initial row plus the index will be what row we draw on. Okay, so the loop in 173, it's going to take that array like scaffold and look at the current index's position in it. So basically at plus in line 176 is to load the right index for the array. Okay, so we got that scaffold array. And we'll check, is it empty? If it's empty, well, then we're at the last string that's an empty string and we want to stop drawing. So it'll exit the do loop down at 188. And if it's not empty, then there's something to draw. Okay, so we'll draw index and draw row. We'll add those together. And we'll get draw column on the stack. So now we have the string, because it was there when we entered the do, with on top of that the row and on top of that the column. Well, that was exactly the stuff that draw at wants. Okay, and so we'll call draw routine in 184. We'll load it up and then call it in 185. And so if it's calling draw at, it's going to do screen move to that consumes the column and the row, and then it's going to do print, which takes the string and removes that and prints it on the screen. All right, and so if that's all good, then we're going to increment draw index and go back around the loop and see if, are we at the last row yet? And so that'll work its way through the array, printing each string and stopping when it hits the last row. All right, and what that looks like is, here's the scaffold array. It allocates 8 lines and declares the array, and then scaffold init is a routine to initialize it. So the array name scaffold index 0 gets the string underscore, etc. Okay. Scaffold 1 gets the corner of the gallows, scaffold 2 gets part of the bar, and so on. So when scaffold init is called, it sets that array that way. We only have to call it once because this is a constant. There's no change to it over time. And on the right, you can see what it looks like. Pretty primitive VT100 graphics. So here's the test. So first we declare var test draw count. It's going to keep track of, for the SPY, it's going to keep track of how many times we called this thing. Kind of the most simple assertion we can make about it. And so the SPY has to take the same thing as draw at did, which is column, row, string, and whatever else is on the stack. But its effect is going to be increment test draw count and then pop those 3 values, just like draw at pops the 3 values. Okay, so we're going to use that SPY in the test draw routine. Line 47 just prints the name of the test so we can see that. Line 48, we initialize draw count to 0. And then line 49, we simulate calling it. So we call scaffold, row, column, and the routine draw at SPY, and then call the draw method. So we've changed what we're going to run. We're not doing draw at now, we're doing draw at SPY. And then we just assert that once it comes back, the test draw count is equal to 7. So it should have 1 for each line in that scaffold. And finally for the week, we started working on game over and initialize. So game over, we have a beginner version for now. It just checks that the guess is equal to the answer. And if the guess is equal, the game's over. If not, we're not over yet. Now, in the long run, we'll also check and make sure you haven't exhausted your guesses, but this will get us going for now. It gives us kind of an infinite number of guesses, I guess. All right, and then initialize is basically going to turn the answer into a starting clue. So if the answer is fish, it's going to become 4 underscores. And this is in progress, so we'll pick up there next week or this coming week. All right, so coming up, we're going to do string to array. Basically, we don't edit strings directly. We move them into an array if we want to work with a big string. Kind of like string buffer used to be in some languages. All right, and then we'll work to finish initialize, get those initial clues. Then we'll work on the game loop. So you know, while we're not done, we're going to read a character, see if it's in the answer, and if not, well, if it is, record the guess. If not, add a body part. And I think if we can get that all done this week, that's pretty much the game. I mean, I guess you could have a loop of multiple games and so on, but it'll get you there. All right, so if you'd like to join us, we meet Monday through Thursday, 2 to 4:30 Eastern Time or 6 to 8:30 p.m. UTC. You can come to xp123.com/Twitch. It'll bounce you over to Twitch for the live session. If you don't want to make it live but still catch things, we do the old sessions are archived at YouTube. xp123.com/YouTube will take you there, and you'll find them about a week or two behind and lightly edited. All right, well, thanks for watching and hope you can join us sometime. Take care. Bye-bye.